Okay. So guys, let's look at the next section, 2.2. And one of the things we're going to talk about are stem and leaf plots. Have you ever seen those before? Okay, a few of you have. If you've done them before, are these things pretty darn easy? Yeah, we're kind of through some of the harder stuff that we're going to cover for the first test. This stuff will probably seem pretty easy. So we're going to talk about how you can construct a stem and leaf chart. A lot of statistics, remember, part of what you're doing is you're just trying to organize and present information in a way that makes it more understandable. All right, so a stem and leaf plot is sometimes a helpful way to do that. And it simply means that I'm going to take whatever my data set is. In this case, if these are the values that I have, and they're all 2-digit numbers, then my stem will be the tens digit. My leaf will be the ones digit. Now, it's really important to know that my leaf side, this is the stem side on the left. This is the leaf side on the right. I guess I ought to use this so you can see where I'm pointing. Stem side on the left, leaf side on the right. You have to make sure, no matter how big your number is, that the leaf is always just the ones digit. And so what it lets us do is organize this where we have a row of numbers in the 20s, a row of numbers in the 30s, and a row of numbers in the 40s. Now, if I were to ask you visually, what does this help you see? What would you tell me? Yeah, you can clearly see we've got the most in which group, 20s, 30s, or 40s? We got the most in the 20s. So it's kind of like a histogram, except the histogram gives us vertical bars. A stem and leaf plot will give us horizontal bars. And the other benefit is it actually contains all the original data values. With a stem and leaf plot, I can put all those numbers back together again to see the original values. With a histogram, I just know which category had the most in it. Okay, now look at this. This is a list of text messages sent last week by cell phone users on one floor of a college dorm. I don't know about you guys, but I'm kind of thinking that this guy right here probably needs a few more friends compared to everybody else. All right, display the data in a stem and leaf plot. And by the way, if you guys are anything like the way my kids are, whenever we would get our cell phone bill and you see what the number of text messages, this looks low to me. Have you guys ever looked at how many text messages you send in a month? Are you guys texters or do you call?
I don't talk to anyone.
So you're just a recluse, huh? Okay, so here's my question. Let's say we want to put this data in the form of a stem and leaf plot. Can we do it? Okay, and the rule was that which side has only a single digit in it, the stem or the leaf? The leaf has to be just the ones digit. So on this plot, most of the listings in the stem side are going to be how many digits? 2. We only have this one kind of lonely person that has under 100 text messages. So if we're going to organize this, then we would need to pay attention to what's the smallest number and what's the highest, because I don't need to start with 10s or 20s. The smallest number was 78. So what would I probably want to put as the first number on the stem side? A 7. And then, do you see anything that's in the 80s? No, so I'm not going to have anything in that row. In the 90s, now, do you see some in the 100s? Like 10 something? And then that means if I pay attention, the highest number in the list is what? 159. I do not see anything in the 160s, but I do see this 159 right here. So that would mean on my stem side, I want to start at which number? And go up to 15. Okay, now let me tell you one other thing that's going to be important. You see how this is written here, where it says 78 is equal to 7, and there's this vertical line and an 8. Okay, and then you could take the number 159 and you could write it as 15 and a vertical line and a 9. This is called your key, and that's something you're going to have to provide so people understand how to read your stem and leaf plot correctly. The reason is, suppose all this data was listing something in thousands. Maybe 78 was really representing 78,000. And 159 was representing 159,000. You would need to be able to show, if this is supposed to be 78,000, that in your key you would show that's equal to 78,000 right here, that 78,000 would be equal to that. Okay, so the key is important so somebody understands how to read it. This is pretty logical because you still keep all the digits and there aren't any extra digits we left off anywhere. So we're going to have to go from 7 to 15 to the left of the vertical line. You got your pencil, you got your notes, right? So this is what you're going to be putting on there. You need a vertical line, and the left side is which one? The stem or the leaf? Stems are on the left, and you're just going to number from 7 to 15. Don't skip 8 and 9, even though we don't have anything in the 80s or the 90s. All right, while you're doing that, I'm going to put it on the board. So let's see how you're doing at this point. Okay? If you look on the left side, this is what you would get if you write them down as you see them looking on your sheet of paper. Do your rows look kind of like these? Notice this key is here. Do you have to have a key when you do a stem and leaf plot? Yes, you do. So make sure you can pick any number you want to use for the key, but you have to have a key so people know how to read it. Now, I can tell from looking at this one over here, I would have the most number of text messages falling in which group? Looks like, yeah, the 120s, okay? The most are in the 120s. This is pretty close, and in fact, you could conclude just from looking at this, because this is longer and this is longer, and this would be right in here would be the third longest. You've got more than half of these users that sent between 110, 130 text messages, okay? So that would be easy to just visually see some data. I mean, definitely, I can tell these are going to be the longest, but maybe I would be interested in knowing what was the most frequent number of text messages sent. I might have a hard time telling when it's written this way. What have they done in this list over here? This is put in order from least to greatest for the leaf part. So they took all of these, and then you can see there's 3 different times somebody had 112. There was 3 times you had 109. What do you think is going to be the number of text messages that occurred most often? Looks like 126, because if I'm looking over here, I see 1, 2, 3, 4, 5 6s. And I don't think I have anything else that repeats that many times. So not only will it give me a quick visual of which group would have the most in it, but if I organize them that way, I can actually see what number occurs most often. All right. And what is that called, by the way? The number that occurs most often? The mode. Good. We're going to be talking about that a little bit later too. Now, here's something else you could do. I will not ask you to do this on a test, but we could take that same group of data they showed us early on, and we could put it on what's called a dot plot. Do you see how this, first of all, would you say that it still contains every individual point in the data set? Yes, as opposed to something like a histogram that just puts things in groups. I can still tell where I would have the highest frequency because I'd see where I have the most dots stacked up. But that looks like that might be kind of a pain, doesn't it, to write it out that way, because I've got this number line and I've got to account for all the numbers. So we're not going to make one. We just know we could. Pie charts. Have you made pie charts in the past? There is a process involved in making a pie chart. Can you tell me how you do that? Oh, very good. She just said you have to have the relative frequency. Isn't that right? Because I need to know what percent of the data needs to be represented on the pie chart. So I would go through all the steps of a relative frequency to come up with that. Now, I don't necessarily have to put it in, I'm not going to be putting it in class limits and boundaries, but I am going to have the individual groups listed. And then I would get the relative frequency. And then how do I get it actually onto the circle correctly? It says the area of each sector is proportional to the frequency of each category. So let's say I have a section and it's supposed to be 65%. How would I know how to show 65% of a circle? How do you measure a circle? Usually you measure it in what unit? Say it a little louder. Degrees. How many degrees are in a circle? 360 degrees make one complete circle. So if I wanted to show 65% of a circle, how do you think I'd figure out how many degrees that is? 65% times 360. 65% of means times. So I could change the 65% to 0.65, multiply it times 360, and that would give me the number of degrees. Now, here's what I want you to do. We're not going to actually make the pie chart on the test simply because you need some extra tools to do that. What tools do you need to make a pie chart correctly? You're going to need a protractor because you got to measure angles, right? And you probably need a compass to draw a circle the right way. So that's a little time consuming. It requires extra tools. We won't do that on the test, but I will ask you to be able to calculate how many degrees each section of the pie chart should be. So you would be able to at least illustrate that. So let's practice with this. This tells you the number of degrees conferred in thousands in the year 2007. So we're supposed to use the pie chart to organize the data. So this would be an example of if you had all the individual things listed and you were doing a stem and leaf plot, that 728 doesn't actually mean 728. It means what? 728,000. So that would be a reason why you would need a key on something like that. This is just making it where the numbers are more manageable. So let's talk about how we would set this thing up. Okay, so you guys have been calculating these. After we added up, got 3007 in the frequency column. We calculated the first relative frequency. We went 3 places to the right because we got 0.242. They've got 0.24. Are these the values that you're getting for these other categories? 0.51 for bachelor's, 0.20 for master's, 0.03 for first professional, 0.02 for doctoral. If you went 3 places, obviously we've got another digit out there. What should that column add up to be? 1. Remember, relative frequency should add up to be 1 because that's equivalent to 100%. Now, is it okay if it's not exactly 1, but maybe it's 0.99? Yes, because these were rounded, so we may be off by just a hair, but as long as it's very close to 1, we're okay. All right? Now, let's talk about how do you get the pie chart from that. We'd have to have an angle measure that would correspond with this. So in order to do that, we're going to, remember, if you have an angle where the vertex is at the center of the circle, it's called a central angle. And that would mean whatever we get for this decimal number in the relative frequency column, we multiply it times 360, and that'll give us the amount in degrees. And that one will round to the nearest degree, okay? So as an example, on the one that's in the first column, if we just use the 0.24 instead of 0.242, when I multiply that by 360, that's about 86 degrees, right? Okay. Calculate the other columns for me. And see how you guys did. Are these the degree measures you came up with? Okay, you could be off a hair on rounding depending on how, if you kept the 3 digits to the right, it might have skewed things just a little bit. This is what they got using 2 digits to the right on the relative frequency. Now, just like we said that the relative frequency column should add up to be the number 1, what do you think the angle column ought to add up to be? 360. Is it possible it won't be exactly 360? It could be 359. It could be 361. That means you can look to see when you did your rounding where's probably the best place to fudge a little bit if you were actually constructing it. But that's what you would need to do to construct a pie chart. Now, this is what that pie chart should look like when it is done correctly. Notice the biggest section in the circle better be what? Bachelors, because that was 51%, which is 184 degrees. Okay? Listen. Shh. And then these sections would match up percentage-wise. So when I look at this, I get a pretty good idea of how this should separate out. Now, I want to just kind of give you a heads up. I believe that person's did not. Okay. So that's everything that is in 2.2.